From skyscrapers that seem to appear almost overnight to entire parks created with 3D printing, from airports that float on water to augmented reality reshaping construction itself, China is not waiting for the future, it is building it right now. What you're about to see are massive projects so advanced they make the rest of the world look like it's a century behind. Mini Sky City. Back in 2015, China stunned the world with a project that defied everything we thought we knew about construction. A skyscraper, not built in years, not even in months, but in just 19 days. They called it Mini Sky City, and it became a living example of how innovation can bend the rules of time. Soaring 670 feet into the sky, this 57-story giant didn't rise through conventional construction. Instead, it was assembled piece by piece using modular design. Entire sections were prefabricated in advance, shipped to the site, and then stacked together like the pieces of a massive Lego set. Once in place, the structure came to life at a pace so fast, it seemed almost unreal. Watching an entire skyscraper emerge in less than 3 weeks feels like witnessing the future unfold before your eyes. But what's even more mind-blowing is what came next. The same company behind Mini Sky City revealed an even bolder plan, a 220-story tower built using the very same method. To put that into perspective, Mini Sky City is only 57 stories tall, meaning their next project would more than quadruple it. It's a reminder that in China, ambition has no limits, and as you'll see in the next project, they're prepared to push those limits even further. Kaila Power Station. High in the mountains of China, where freezing winds cut through the air and temperatures plummet to -30 degrees, stands one of the most extraordinary power plants ever built, the Kaila Power Station. What makes this site remarkable isn't just its brutal environment, but the daring vision behind it. Unlike most power stations, Kaila isn't fully hydro, nor is it fully solar. Instead, it combines the strengths of both. Spread across an astounding 170 million square feet, vast fields of solar panels work in harmony with powerful hydro systems, together generating over 1 gigawatt of clean, renewable energy. This is not only the largest hydro PV plant in the world, but also one of the most ambitious, built in conditions that most would consider impossible. Perched at extreme altitude against the forces of nature, it stands as proof that innovation can conquer even the harshest landscapes. And if that wasn't mind-blowing enough, what you'll see next takes things to an entirely new level. AICT 3D printed park. Picture this, an entire public park covering nearly 60,000 square feet, built not with traditional tools, but entirely through 3D printing technology. That's exactly what China unveiled with the groundbreaking AICT 3D printed park. Every detail, from the benches to the sculptures, from the flower beds to the retaining walls, was crafted by massive 3D printing machines, using concrete as their medium. The result is a flowing landscape of smooth, wave-like designs that seamlessly blend into one another, an architectural style that feels futuristic, almost otherworldly. Even more astonishing is the speed. Despite its enormous scale, the entire park was completed in just 2.5 months, at a fraction of the cost of traditional construction methods. It's a bold showcase of how 3D printing isn't just a novelty, it's becoming a cornerstone of modern building in China. And this isn't the only proof. Their next achievement takes 3D printing to an even larger scale. Shanghai 3D printed pedestrian bridge. When you think of 3D printing, you probably imagine small objects, maybe furniture or decorative pieces. But in Shanghai, engineers used it to build something far more ambitious, an entire pedestrian bridge. Stretching almost 86 feet, it holds the title of the largest 3D printed bridge in the world. Constructed in just 450 hours by 2 robotic arms, the bridge is made of 44 hollow concrete units for the main span and 66 more pieces forming its curved handrails. Its elegant wave-like design doesn't just complement the landscape, it makes the structure look like a piece of art. And just like the 3D printed park, the bridge was faster and far cheaper to build than traditional methods, proving once again that China is years ahead in adopting construction technology that the rest of the world is only beginning to imagine. But as impressive as that is, what China built next is on a scale that redefines possibility itself. Huayi Shikumen Complex relocation. What do you do when a historic landmark stands directly in the path of new development? Most places would make the difficult choice to demolish it, but in China, the answer was far more ambitious. They decided to move the entire building. The challenge came when city planners wanted to construct a massive underground shopping center, a parking facility, and subway connections beneath the Huayi Shikumen complex. But rather than sacrificing this century-old treasure, engineers turned to technology that seemed almost science fiction. The solution? A fleet of robotic hydraulic jacks. Together, they carefully lifted the 8,270-ton structure off the ground and began shifting it forward, step by step, like a giant mechanical walk. Slowly, the building was relocated, making way for the construction below. Once the underground project was completed, the entire complex was moved back to its original place, unharmed and intact. The result was nothing short of extraordinary, a perfect balance of preserving history while pushing forward with progress. And if you think that's innovative, wait until you see what comes next.
Huangjiang Canyon Bridge is not just another construction project. It's a record-breaking feat of human engineering. Rising more than 2,000 feet above the valley floor, this colossal structure is set to become the highest bridge on Earth, overtaking the previous world record held in the very same province. Building something at this altitude posed a challenge unlike any other. Traditional cranes couldn't even reach the site, let alone handle the massive loads required.